So this is the fourth video covering activity 4.2. Again, we were dealing with the position function or the height function. This gave us the height of an object at any given time, and we answered a few questions. And in the last video, we figured the horizontal intercept. We calculated the horizontal intercept with our graphing calculator. If you recall, I had graphed y1 was the function and y2 was 0, and then I found the intersection between the two lines that I graphed. Right, the red line is y2 and the blue line is y1, and the intersection occurred at these 2 points, 11.1 and negative 8.1 comma 0. But let's get rid of or delete y2. Okay, so now when I graph, there is no red line. I only have the blue line. I still want to determine the points where the blue line crosses the horizontal axis, right? So that's the horizontal intercept. If I press second on my calculator and then I press trace, because above trace it says calc, you see where it says zeros, number 2? So I press number 2. Essentially, we want to find when y equals 0, what are the values for x? Okay, so notice on the bottom of my calculator it says left bound. That's saying move your cursor to the left of where you think the intersection occurs. So if I think the intersection occurs, or the intercept is right where my cursor is blinking, I want to go to the left of that value. So I press the left arrow a few times. So now I'm to the left of that point. I press enter. Now it says right bound. So I'm going to go to the right, or move my cursor to the right of where I think the intersection occurs. I press enter, and then it says guess. So the guess has to be in between. I press enter, and you'll notice it said, okay, the 0. Y is 0 when x is negative 8.1, which is what we had down here, right? That's what we found originally. And I can do this exercise again. If I press second and trace, number 2 for 0, it says left bound. So I'm already to the left, right? Because if I want to find this intersection over here, I just need to be somewhere on the left. So anywhere over here is to the left of this point. So I press enter. Now it says right bound. So I have to move my cursor to the right. So now you see my cursor is to the right of that intersection. So I press enter. And it says, guess where do you think the intersection is? And I think it's somewhere around here. I press enter. And you'll see it says y is 0 when x is 11.1, which is what we found the other method. So now you have two methods to find these horizontal intercepts. The last part is the practical domain and range. So we've already determined the domain and the range. Practical domain. Right, well, the domain is all real numbers, meaning the value of x or the value of t in this case, our input can be any number. But practically speaking, time 0 is when I'm on top of the building, and this horizontal intercept, which we found to be 11.1, is when the ball hits the ground, right? The ball is only in the air for about 11.1 seconds, right? Right, because at 11.1 seconds, the position or the height of the ball is 0. At 0 seconds, the ball is 1,450 feet in the air, right? So from 0 to 11.1, that's how long the ball is in the air. So the practical domain is from 0 to, let's just call it 12 to be safe. All right, so I wrote the domain is from 0 to 12. Now, if you wrote 0 to 11, I would take it. And looking back on the problem, they used t instead of x. So perhaps you'd want to actually write t is between 0 and 12. Okay, I know most of the graphs we deal with have x for the horizontal axis and y for the vertical. In this case, they use t for time. So a better answer would probably be t is between 0 and 12. For practical range, again, the maximum height of the object, it's not the 1,450 feet, right? The initial height of the object is 1,450 feet, but the maximum height occurs at the vertex, the top of the parabola, And from the first problem, we determined that the vertex, or the highest point in the parabola, was this 1,486 feet. And then the ball's going to eventually hit the ground, which would be 0. So my practical range would be somewhere between 0 and 1,486 feet. So here's my practical range. And notice how this differs from my actual range, right? So the range, we said y could be any number less than 1,486. So remember, that means this y for the range could be -10, -1,000, -1,000,000. Whereas the practical range, we're saying, listen, the ball's going to hit the ground and stop at 0. It's not going to go negative. So the range, all the possible heights that make sense in the context of this problem would be between 0 and 1,486 feet. I think that completes lesson 4.2, or activity 4.2. Thank you for watching.